Hello everyone. Welcome back to our tutorial series on game theory. In today's video, we will be focusing on graphical method in game theory. The graphical method is used to solve the games whose payoff matrix has two situations which can be of 2 rows and n columns, that is 2 into n, or m rows and 2 columns, that is m into 2. Graphical method is the simplest method among all other methods in the game theory. Now let's see the first type of graphical method, that is 2 into n, 2 rows and n number of columns. Here we will take the 2 rows and draw 2 vertical axes 1 unit apart. Take the points of the first row in the payoff matrix on the vertical line x1 and the points of the second row on the payoff matrix on vertical line x2. The second step is, here the player 1 has 2 strategies and the player 2 has n strategies. Let p and 1 minus p be the probabilities which player 1 uses his pure strategies. In this, player 1 will select the value of p which maximizes the minimum expected payoff. For this, we will draw the lines representing the strategies of player 2. The next step is, the lower boundary of these lines will give the minimum expected payoff. The highest point on this lower boundary will give the maximum expected payoff of player 1 and hence the optimum value of p. The line which passes through this maximum point represents the optimum strategies of player 2. This in turn gives the optimum solution as 2 into 2 matrix. For more clarification, let's see an example. Let's see an example for 2 into n matrix. In this problem, we have 2 players, that is player A and player B. In player B, we have 5 strategies, that is B1, B2, B3, B4 and B5. And player A has 2 strategies, that is A1 and A2, where the values are 2, minus 3, minus 4, 4, 6, minus 4, minus 3, 1, 5, 0. By dominance property, we know that B5 dominates B1. So we are going to eliminate B5. Now the payoff matrix is player B's B1, B2 and B3 and player A has A1 and A2. Thus, this is the 2 into n matrix where n is equal to 4. Let's draw 2 vertical lines A2 and A1. On both A1 and A2, mark the points. So the maximum row value is 6 and the minimum row value is minus 4. So we are going to mark the points from 6 to minus 4 on both the lines A1 and A2. Then draw the lines representing B1, B2, B3 and B4. To draw the line B1, take 3 on A2 and 2 on A1. We are going to take 3 on A2 and 2 on A1. Then join them. Similarly, draw B2, B3 and B4. Here we get a lower area bounded by the lines B1, B2, B3 and B4. Width is LMNOP. Therefore, this is the n is the required point as it is the maximum point. Here we can see that n is the maximum point. Thus, the reduced matrix is obtained by avoiding B2 and now we get the maximum point n and it is the intersection of B1 and B4. So we are going to ignoring or avoiding B2 and B3. There we get the reduced matrix B1 and B4, A1 and A2, that is the values with 2, minus 3, minus 3 and 1. Now we are going to get the optimal strategies for A, choosing A1 and A2, which is applying the formula P is equal to D minus C by A plus D minus B plus C, where we are going to substitute the values, that is A for D, 1 minus 3 by 1 plus 2 minus 3 minus 3, which is equal to 4 by 9. After getting the p's value, we are going to substitute the p value in 1 minus p, where we will get 5 by 9. Then we are going to find b's optimal strategies for choosing b1 and b4, where q is equal to d minus c by a plus d minus b plus c, which is equal to 1 minus 3 by 1 plus 2 minus 3 minus 3, where we get this answer as 4 by 9. After getting the value of q, we are going to substitute the value of q to 1 minus q, which is equal to 5 by 9. Finally, we have to find the value of the game. So for finding the value of a game, where we are going to give the formula, that is v is equal to AD minus BC by A plus D minus B plus C. After substituting the values, we get 2 minus 9 by 3 minus 3, which is equal to minus 7 by 9. Therefore, we have A strategies, that is 4 by 9 and 5 by 9. And B strategy is 4 by 9, 0, 0, 5 by 9. Here, zeros represents the values for B2 and B3. Then, value of the game is minus 7 by 9. Hence, we get the 2 into 2 matrix values and the strategies to be selected. Now, we are gonna see the second method, that is m rows and 2 columns, that is m into 2 matrix. Here, we are going to draw 2 vertical axes 1 unit apart. Then take the points of the first column in the pair of matrix on the vertical line y1 and the points of the second column in the pair of matrix on vertical line y2. Then here the player 1 has strategies m and player 2 has 2 strategies. Let q and 1 by q be the probabilities which player 2 uses his pure strategies. In this, player 2 will select the value of q. For this, we will draw the lines representing the strategies of player 1. Then we will collect the upper boundary of these lines will give the maximum of the loss. The lowest point on this upper boundary is minimax point. The lines passing through this minimax point represents the optimum strategies of player 1. This in turn gives the optimum solution as 2 into 2 matrix. Now let's move on to an example to see how it works. Here we have 2 players, player A and player B, where player A has 5 strategies and player B has 2 strategies. So we can see that the values are minus 6, 7, 4, minus 5, 1, minus 2, 2, minus 5, 7, minus 6. So, in the first step, we have to draw 2 vertical lines, that is B2 and B1. Then, we are going to mark the values on B1 and B2. After marking the values are 7 and minus 6, 7 to minus 6. It's because the highest column value is 7, the lowest column value is minus 6. So, we are going to mark from 7 to minus 6. Then draw the lines of A1, A2, A3, A4 and A5. To draw A1, take 7 on B2 and minus 6 on B1. Now we are going to join them. After joining, we can see a line representing strategy A1 where the values is minus 6 on B1 and minus 7 on B2. The boundary of the polygon is LM and O. So, the lowest point on the upper boundary is N, which is our minimax point. Now, we will get the lowest point N, and it is the intersection of the lines A4 and A5. So, we are ignoring A1, A2 and A3. Thus, the reduced matrix is B2, B1 and A4 and A5 with the values minus 2, 5, 7 and minus 6. Let's find the A's optimal strategy for choosing A4 and A5, which is P is equal to minus C plus D by A plus D minus B plus C. In this formula, we are going to substitute the values, that is minus 6 minus minus 7 by minus 8 minus 12. Here we will get answer as minus 13 and minus 20. Final, the answer is 13 by 20. After substituting the value of p in 1 minus p, we will get 7 by 20. Now, we have to find B's optimal strategy for choosing B1 and B2, which is Q is equal to D minus C by A plus D minus B plus C. After substituting the value, we will get minus 6 minus 5 by minus 8 minus 12, where the answer is 11 by 20. After getting Q's value, we are going to substitute Q value to 1 minus Q. Then we will get the answer is 9 by 20. Finally, we have to find the value of the game. So let's find the value of the game, which is B is equal to AD minus BC by A plus D minus B plus C, which is equal to 12 minus 35 by minus 8 minus 12 equals to minus 23 by minus 20. The final answer is 23 by 20. Therefore, now we have A strategies, B strategies and the value of the game, which is A strategies with 0, 0, 0, 13 by 20 and 7 by 20, where the 0 represents A1, A2 and A3, and B strategies with 13 by 20 by 7 by 20, and value of the game is 23 by 20. Hence we find the answer and the solution for M into 2 matrix. Finally, we have come to an end of the tutorial. Thank you for watching.